This is the video for homework 1 and the explanation for the 4 word problems or example problems that we had to do with math. So for the first problem, we had to find thermal conductivity, and we were given basically everything else. We just had to rearrange this simple equation. So we had Q, we had the temperature difference needed, and we had an area, and we just had to solve for Q, or solve for H in order with all of these values. The only tricky part was because there were two walls, you had to divide 25 by 2 in order to get the thermal conductivity through each wall, and then you also had to multiply by the thickness of the walls in order to get the final thermal conductivity. That's how this first problem is done. The second problem, we were looking for the rate of heat loss from this pipe here, which is at 200 feet, and then its diameter of 4 inches. So we basically just use this same Q equation that we used in the problem before. We just have to have a different area because it's pi dl and it's a cylinder. So we just do pi dl to find our area, and then we get our rate of heat loss ended up being quite large, 289,000 BTUs per hour. Then we had to solve for the cost of this, or how much it would per year. So we have to multiply this by 88,760 hours per year, and then that gave us how much BTUs per year. And then we wanted to find at 86% efficiency, so we were looking for Q, so we had to divide the energy per year by the efficiency in order to get the actual efficiency of this steam pipe. And then we just had to multiply it to do our units. We had to multiply it by $1.10 and then divide by 1,000 in order to get the therms. They gave us $32,000 a year. This third question had to do with absorptivity. So we just have this simple Q equals epsilon sigma t to the fourth, but because of absorptivity, and this is Q over A because that was what we were given, so we just have to multiply by absorptivity and solve for T. So this is we just divide everything over and solve for T, and then to the fourth power, or to the fourth root, and then we're ordered to get 281 degrees Kelvin. And then for the final problem, we were looking for binary diffusion coefficients, and so these diffusion coefficients at the temperatures of the specified temperature, but they're all given at 1 atm, and this is from table 14.1. So for A, because we're at 200 Kelvin and 1 atm, the value is the same, but each time we had a different pressure, we had to divide by the pressure that we actually had. So for B, it's divided by 0.5 atm, and C is 5 atm, and you get these final values. The only confusion or question that I would have would be, what exactly is binary diffusion, or diffusion, because I don't really remember talking about it, and I'm not sure 100% what it is exactly. So that would be my question of the day.